On the evening of July 29, 2026, a fireball erupted between two industrial tankers at Egypt's Damietta Port, lighting up the Mediterranean coast. The vessels involved were the U.S.-owned floating terminal Energos Winter and the LNG carrier Gaslog Salem. At the time of the blast, they were in the middle of a high-pressure fuel transfer. This diagram illustrates a blave, a boiling liquid expanding vapor explosion. When an external fire heats a sealed LNG tank, the liquid inside boils into gas, causing pressure to build until the steel walls rupture, releasing a massive shockwave. The fire at Damietta stood seconds away from triggering this sequence, a vaporization event powerful enough to flatten the terminal and the surrounding docks. The Egyptian Ministry of Petroleum moved quickly to manage the story, framing the incident as a contained operational fire with zero casualties. But intelligence assessments from the security firm Ombre and reports from Reuters contradicted the official line. Their data pointed to a deliberate drone strike. The primary target, the Energos Winter, was a U.S.-owned asset. Striking it was a calculated move against American energy infrastructure in the region. With the confirmation of a strike, the conflict had jumped from the Persian Gulf to the eastern Mediterranean, turning one of Egypt's most sensitive economic hubs into an active front. While the explosion threat was real, total catastrophe was avoided through specialized engineering designed for this scenario. This infographic details the GTT-96-2 membrane protecting the Energos Winter. Tanks are lined with a 0.7 mm Invar alloy. Because it barely expands when heated, this thin membrane isolated the liquid gas, kept at -162 degrees Celsius, from the outside fire. Mechanical failsafes provided a second defense layer. If ships drifted 5 meters apart, the ESD-1 system automatically shuts down transfer pumps. At a 7-meter drift, ESD-2 triggers a mechanical dry brake, instantly sealing hoses, preventing gas from feeding the fire. The terminal remained intact only because these systems, operating at microscopic tolerances, triggered exactly as designed under extreme pressure. But the precision of the ship's engineering was matched by the precision of the attacker's strategy. This section of the report highlights a revenge map broadcast by Iranian state television just 2 days before the attack, explicitly listing Western energy assets as targets. The strike coincided with a series of U.S. military operations in Iraq and missile launches toward Jordan, signaling a coordinated escalation across multiple regional arenas. Damietta was a priority on that map because it serves as the primary gateway for Egyptian gas exports headed to European markets. The drone strike wasn't an isolated act of violence, but a surgical move designed to choke a vital node in the global energy supply chain. Even though the fire was extinguished, the event triggered an economic reaction that the port's physical defenses couldn't contain. Within hours, the regional insurance market shifted. Major protection and indemnity clubs revoked war risk coverage for any vessel entering the eastern Mediterranean or the Gulf of Suez. Global shipping lines responded immediately. This table shows companies like Hapag-Lloyd imposing emergency surcharges up to $4,000 per container. And these graphs track the energy fallout. Brent crude rose 8%, while analysts projected a massive spot price increase for Asian LNG. By bypassing the port's physical armor and striking at its balance sheet, the attack forced the global shipping industry to immediately price in a much higher level of risk for the region. For Egypt, the strike exposed a deepening strategic fragility. The country has recently transitioned from a gas exporter to a heavy importer just to keep its national power grid operational. Egypt now relies on a constant flow of gas from offshore Israeli fields like Tamar and Leviathan. This map shows how that gas travels through undersea pipes directly into the Damietta infrastructure and the floating terminals anchored there. This creates a state of asymmetrical vulnerability. A strike on this shared infrastructure can threaten Egypt with immediate blackouts, while the suppliers and attackers remain insulated from the domestic fallout. Human engineering is precise enough to stop a massive fire from triggering a chain reaction explosion, but that same engineering has yet to find a defense against the economic shockwaves of a regional war.